In our last video, we added the initial solver for our Minesweeper game. As you can see, it solves that cell. This cell, because it knows it can't have any neighbours which contain mines, and finally this one here. In this short video, we're just going to tidy up the code a bit from last time because we cheated a bit with our tests. So the first thing we're going to do is rename this method here. Try does cell contain mine count. I think that should be try get cell. Try get cell. Oh, maybe it's try get mine count for cell. I think that makes a bit more sense. And the reason we cheated is we actually added this line of code without having a failing test. So if I took this line back out, I'll tell you what that means. So without that line of code in, it means it correctly solves the first cell, but then won't go on to solve any subsequent cells because it keeps retrying that first one. But the problem is our test was only looking at this very small area. So what we need to do is extend our test to cover the entire board. And then we can then call solve twice, the first time to solve that cell, and the second time our test would assert that it's solved that one. So at the moment we're just loading the state in by manually populating an array. I think what might be nicer is if we could load it from a string, which would look a bit like our initial state. So let's add a helper function. And let's turn white space off for a second. Okay. So it's going to be similar to our code for loading the game from a file, but instead of it coming from the file up here, we're going to come from our string. So I think we can copy all of that code. And say lines equals dot split and yeah, it's a bit. Maybe we should have it more like that. Okay, I think that's a bit easier to read, isn't it? Okay, so we load all the lines in, we split on the new lines, so number of columns is the length of the first line, the number of rows, the number of lines we've got. Then we can build our initial state while we loop for each one. So that should work. So become that. In this case, we do the load, and we can just test our test still passes. Which he doesn't. Right, that's quite interesting. Why? Okay, let's debug that, I think. So that's correct, that should be solved, that's that cell there. But it hasn't found either of those two. One across. That's the one it's just solved. Okay, so P01. Oh, that's not right, is it? Ah, yes. The problem is we've removed our carriage returns, so let's add commas in instead. So it is loading the board in as a single line. Let's try it. Okay, that's much better. Right, so the next thing we should look at is, as part of the assertion, is we check we're getting the right solution back, which is fine, and then we check that we've correctly modified the 3 cells in our game. But what we're not doing is checking that we haven't modified the rest of the board. So I think what would be quite nice is if we could assert the entire board. So we would need a function we should take in the board we actually got and how we're expecting it to look. So in this case we're expecting these 3 round here to be misses. So most searches are expected then actual, so we put our parameters that way around. I'll comment those out for a second. And create that function. Right, so we've got expected board, which is that, and actual game. Right, it's going to be similar to this code. So we just need to, so what we're expecting is that, we should mark it. And then what we actually have so the only thing that I'm not sure of, yes, unknown we treat differently. So if it's blank, we can change that to be a space. Okay, let's try that. Okay, that's gone green. Good. So now we can create a test for solving that one. And the easiest way for the moment will be to copy our existing test. Say solve second cell, and we will just solve all that twice. After the second one, which is down here, so we'd expect that's what we're hoping for. But at the moment our test should fail. Okay, yeah, and the other reason is 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8. Our set of interest will be 0, 1, 2, 3, and 7, 6, and 0, 1, 2, 3, 4, 5. 0, 0, 1, 2, 3, 4, 5. Being 5. No. So 0, 1, 2. And finally, no 7. Okay, it's better. It's correct error. And with any luck, we can put our code back in on our tests, and we break it. Okay, that's much better. Right, so to summarise what we've done, we've added 2 helper methods, one which allows us to create the initial state of a board from a string, and another one that allows us to assert the current state of a board again from a string. And then we've used that to test for playing our first move and also for playing our second move. So now we're in a position for the next video to start doing our second method, which would cover cells like this one where we know one of its neighbours must contain a mine and there is only one empty space.